Hey, Year 11, thanks for coming along, guys. Now, guys, I've been having major issues with my microphone this morning. What I need to do is I need to take apart... Oh, can't hear anything yet. Oh, that's weird. Like, actually no sound? Audio. That's weird. Oh, I don't know why. It's putting through the... That's weird. Can you guys hear me? Sounds better on the meet. I can't hear myself. That's really weird. Sound seems fine. That's strange. I can't hear myself on the YouTube channel. I don't know how to... Okay, I'll continue anyway in that case. I'll pop out the chat, and there we go. Pop out the chat. If the sound goes wonky donkey, which it will, it'll start crackling and you'll get static, and I apologize. I am going to fix it. Is your sound on? Yeah, I think my sound is on. It's rather odd. Something's happened here. I need to sort this out. I found it. Found the problem. Fixed. Yeah, when the sound goes crackly, just post on the chat and then I'll fix it. I am going to take everything apart after this lesson, and at break time just clean everything with an alcohol wipe just to try and... I actually ought to use a metal cleaner, take the oxide layer off. The problem is I bought cheap cables, cheap splitters, and they're not doing any good. Anyway, let's crack on with today's lesson. It's going to be a short lesson, which will be nice. So we're just continuing with the process of combustion, finishing that off. Camera, let's switch to that one. There we go. Yeah, let me know when the sound goes wonky. So you guys, there we go. So this is today's lesson. Fingers crossed it doesn't ruin it. I'm gonna move it. There you go, flipping it into tablet mode, and then it kind of all goes through a bit screechy. Let me know if it's still working now, guys, because I'm now switched to tablet mode. The cables have been jiggled, but they're now hopefully should be okay. So 3 learning objectives today, guys. Number 1, no problem each gas causes. Yeah, next, no treatments for each problem, and then write equations for the solutions. Chemistry has all the solutions. Okay, right. So first of all, problem gases of combustion. So we've done this before. You'll remember this diagram, folks. You'll remember this diagram. There we go. So the question is, what's coming out the back of your car? That is the question. So we're going to get a whole load of different things in here. We're going to get, number 1, carbon dioxide. We're going to get, number 2, we're going to get water vapor as a gas. That's important, by the way. State symbols are important. We're going to get carbon particulates. We're going to get carbon monoxide gas. We're going to get sulfur dioxide gas. We're going to get nitrogen dioxide gas. Cool. We're going to get a whole variety of these. All these gases come out the back of your car exhaust. And the question is, what are each of these what's the problem with each of these gases? So we've discussed a couple already. So let's just list the problems that we're going to see. So on the chat, please, carbon dioxide, what's the problem? What does it cause? And by the way, I obviously, there's one top answer here, but there is a second one as well, which I'll talk about in a minute. Carbon solid, what does it cause? We did this a little bit of this last lesson. Next one, carbon monoxide. We did this one last lesson. SO2, what does that cause? And NO2, what does that cause? And I'm also going to add on water vapor, because that's actually an important one. Cool. I like it. Getting great answers. Global warming. I like it. Global warming. Thank you. It's also, by the way, causing the oceans to become acidic. Ocean acidification. Yeah, I'll give you the equations for all of these in a minute. So global warming, carbon, well done. It's a great job, guys. I like it. Global dimming. Global dimming. Number 2, carbon monoxide is toxic. Binds to blood permanently. Prevents blood carrying oxygen. That's better. I'll put binds to blood to blood, prevent O2 carry. That'll do. Keep it short and sweet. SO2, acid rain. NO2, acid rain. Now, that's where Kieran, sulfurous to salt. Yeah, no, Kieran, you got to be careful. It's sulfurous, not sulfuric. And then water, global warming, amazingly. But that one doesn't really count. I need to talk about this one. I'll talk about each one in turn. So first thing is I'm going to explain each one of these. Explanation. Explain. So global warming, carbon dioxide, CO2 molecules absorb infrared IR radiation, trapping in atmosphere, trapping heat in ATM, atmosphere. Ocean acidification, this is now the ocean acidification. The carbon dioxide reacts or dissolves in water, reacts with the water to form carbonic acid. Carbonic acid. There we go. Next, you now need to explain, I'm going to, global dimming. Don't really need to explain that. Black solid, carbon, solid, black particles in air, block sunlight. Sunlight. Next, carbon monoxide we've already done. Acid, sulfur dioxide, this is where I need to be careful for Kieran. SO2 gas reacts with water in air to form sulfurous acid. Here's the equation. SO2 plus H2O. Just combine them like you did with carbonic SO3. So there's sulfurous acid, and that's now aqueous. Next, NO2. This one's a bit more complicated. NO2 reacts with water to form. Now, this is actually an interesting one because it's probably going to form nitrous acid. Sir, oh, Yusuf. Sir, are you in the UK right now? No, Yusuf, I'm in Malaysia. I'm in Malaysia. That's where I am. So I just want to show you this, the nitric acid one, the nitrous acid. So NO2 acid rain equation. It's slightly more complicated. You don't need this one for your exam, but you need the other one. Let's see if we can find the equation. Images. There we go. Yeah, nitric and nitrous. It's actually a mixture. Isn't that interesting? Yes, you actually get both. Form nitrous stroke nit, but you don't need this one. This one, you just need to know reacts with the water to form nitric acid. You just need to know that that forms acid rain. That's all you need, acid rain. Yeah, you don't need this bit for Edexcel, but it's nice to do the equation, and also it's good for me to do it as well. Two NO2s react with water to form nitric and nitrous, and HNO2. Nitrous is less acidic than nitric. Well done, sweetheart. Yeah. You don't need that one. Sorry, friend, I'm just wondering because it's 1:28 over here. 1:28 in the morning. Why are you awake? Okay, so next, you do not need those equations for any GCSE. I don't know what exam board Yusuf is doing, but he's probably doing AQA most likely. And AQA, you don't require that one either, but you need both of these equations for AQA and Edexcel. You need both of those. They ask those relatively frequently. And the last one is water vapor, right? So greenhouse gases, make a little subtitle, guys. Greenhouse gases include, number 1, CO2. Number 2, water vapor. Do you know it's actually 5 times worse than carbon dioxide? Next, methane. Methane is also a potent greenhouse gas. The other one that you need to know is probably SO2 is not really. Those are the only ones you really need. I'm Edexcel GCSE, but obviously they've been cancelled. Too much stress by Gavin Williams is why I'm up. That's fair enough. These are your main culprits, guys, for your greenhouse gases. I believe NO2 is actually also a greenhouse gas, just so you know, but it never gets asked because it has a much larger function, greenhouse gases. Anything with polar bonds, just to let you know, anything with polar bonds is a greenhouse gas. It's actually, there's the A-level step up, by the way. Just to explain the water vapor, though. So why this one here? So what I should do is I should actually put the methane. These two are the actual culprits. Yeah. And then water vapor is separate. The reason being gas and gas, these guys remain in atmosphere, remain in air. The carbon dioxide, of course, is, we're lucky with CO2 because most of it's dissolving into the oceans, making them acidic. But the methane certainly does stay there. We can put nota bene, some CO2 dissolves in ocean, which is why they're becoming acidic. The great thing, water vapor, this one here, is a greenhouse gas, but comes back down in rain, comes back to ground as rain. Did you know, by the way, out of the hilarity of this is that the most abundant greenhouse gas on average in our atmosphere is water vapor, but it's been consistent all the way through. It doesn't matter how much water vapor we put into the air, the balance actually remains, the equilibrium remains the same. So if you like, you can actually represent the equilibrium as the state change. Yeah. And here's what's happening. Yeah. So this comes back down as rain stroke ocean. And what we realize is there is a balance in our atmosphere. There is a balance in our atmosphere of this equilibrium. And if you add on a power station, and you put loads and loads of water vapor into the atmosphere, yeah, we put loads and loads in it from burning fossil fuels. And what does the equilibrium do? I'm going to ask Isabel. Isabel, what does the equilibrium do if we suddenly pump loads of water vapor into the atmosphere, please? And you're going to run coughs on this, Isabel. Coughs. Equilibrium. Impress me, Isabel. She's not going to do it. Anyone on the chat want to add on to that? So Yusuf, if you've not seen any of my equilibrium ones, this is a method for getting all the marks in equilibrium. So the knowledge is that water vapor is the reactant. It's on the left of the equation. Yeah. So H2O gas is a reactant. Stroke on left. Yeah. Oppose. If we increase H2O gas concentration, equilibrium will reduce H2O gas concentration favors. Equilibrium will favor forward reaction because we've increased this guy. The equilibrium is going to try and destroy it by going that way. Sorry, my video was delayed. No problem. Equilibrium will favor forward reaction. Ooh, favor forward reaction. Shifting left to right. Sorry, yeah, shifting left to right. More rain. Yeah. See, and then yield. Yield of water vapor will therefore decrease. The yield of rain will increase. Technically, because the yield is always about the product. But it's, or you could say, if you like, therefore H2O gas decreases, because we're talking about the amount of greenhouse gas in the atmosphere, so reasonable. Equilibrium shifts to the side and removes it. So it's one of the worst greenhouse gases, but it doesn't matter because it comes back down as rain. Right, what we now need to do is we need to solve each of these problems. Right, so solving, we'll go back to black. Solving problems. Need to be careful on the time here. Just need to make sure I know exactly what time this ends. There we go. Okay, we're only halfway. It's fine. Solving problems. Right, number one, carbon dioxide. So, solution number one. Solutions. Number one, carbon capture and storage. So what we're now doing, carbon capture and storage, is in your power station, we're producing boatloads of CO2. Instead of letting it escape into the atmosphere, what we're doing is we're collecting it. We're actually liquefying it. You cool the CO2. So this gas is now being funneled. It's now being funneled into a cooling chamber, which then liquefies the carbon dioxide, bottles it, and we then store the bottles. So carbon capture and storage. So bullet point number one, CO2 gas is cooled to become a liquid. CO2 liquid. Now, by the way, CO2 liquid's quite interesting because you guys probably know about dry ice. I've done enough dry ice in my lessons and showed you the fact that it's very difficult to make carbon dioxide as a liquid. The reason being is you can't make carbon dioxide a liquid at 1 atmosphere, at atmospheric pressure. But what you can do is squash it. Do you know the way you see in cigarette lighters? You can see that there's a liquid butane inside it. But so what do you do with this? What do you do with the stored CO2? Okay, tongue. Okay, so becomes a liquid, bottle, and store. So here's, okay, if you want the real truth of the matter and where this is actually going. So this is detail you don't need to know, guys. So the oil companies dig up oil out of the ground. There are huge reservoirs of crude oil here. Yeah, full of the black sticky liquid that is crude oil. And what the oil companies do is they set up their drilling platforms, and they drill down into the oil reservoir, and they tap out the oil, and then you get your little, yeah, and that's where our oil comes from. Now, what they're now doing, the oil companies have been genius about this, because what they now do is from the power stations store and bottle carbon dioxide. Yeah, so what's now happening is the oil companies buy it. The oil companies buy it, by the way, for next to nothing, by the way, literally like pennies. In fact, I think they actually make money off it because they're taking carbon dioxide and they're storing it for the people, so they get a tax rebate Oh my God, it's just ridiculous. Anyway, so what they now do is they now drill a second hole. They now drill a second hole that's longer than the first. And what they do is they pump in the carbon dioxide. They pump in the CO2. And it pushes out the oil. So they actually get the oil quicker and store the CO2. So not only do the oil companies get more oil, but then they also get a tax rebate on storing carbon dioxide. It's an absolute nightmare. Oh, it's a disaster. Now, at this point, people go, oh, that feels like we've just solved all of our problems. Yeah, but we're not storing any of the carbon dioxide that the cars are producing. Yeah, we're only doing it in certain power stations, and in China, they're not even bothering. They don't store any of their CO2. They just let it go into the atmosphere because it's way too expensive to do this process. Only you have to have a much more advanced power station, and the cheap ones, China's turning on a coal power station every 2 days, and they're still burning coal. Like, this is crazy. Yeah, like there's potential to store the carbon dioxide, but they're not doing it because it costs way more money to do this. So unfortunately, it looks like a great thing, and it is, but it's not ideal. And plus, it means that we're getting what requires of capitalism. Yeah, okay. Wait, then is is it stored CO2, liquid, or gas? Because they push the CO2 down at crazy high pressure, it's actually going in as a liquid. If you take any liquid, almost. If you take a gas, yeah, you take a balloon of gas and you squeeze it, you squash it enough, yeah, and you turn it into a tiny one, it will become a liquid under high pressure. Yeah, there are times when that's not possible, like oxygen you cannot liquefy under pressure at 298 Kelvin. At room temperature you can't do it, but those are really oddities in terms of what's going on there. But yeah, so they put it in at such high pressure, they squeeze the gas so much, they're putting it in such high pressure it goes in as a liquid. Well, actually, it goes in as a gas and then it becomes liquid in the container because it's under such pressure. And when the reservoir is full, by the way, they then cap it. So when the reservoir is full, they then cap both channels with concrete. And hopefully the CO2, it was literally about to ask the oxygen one. Yeah, you cannot make liquid oxygen at room temperature, no matter what pressure you have. There's what's called a critical temperature. Is it possible for the remaining CO2 to turn into crude oil after centuries? God, Tom, what a great question. The answer is absolutely not. The CO2 will remain CO2. They're actually really, I was going to ask that too. It's a great no. The answer is it's not possible. What's actually really worrying is the fact that we don't really have much knowledge of this. They're worried that the CO2 will leak. It will leach out of the rocks. They're saying that it won't. Yeah, they're saying it might leak out into the oceans, in which case our oceans, if one of these reservoirs popped and all the CO2 went into the water, yeah, the outcome would be horrendous. I don't know where crude oil comes from. Wow, Ashley, you get taught that in year 9. Crude oil comes from, okay, here's the thing of crude oil. So crude oil, box number 1, story number 1. We're in the ocean and there are dinosaurs. There are dinosaur fish. Yeah, let's get a dinosaur and give us some teeth. So these are fish dinosaurs. Yeah, the fish dinosaur then dies. Yeah, fish dinosaur dies. It sinks to the bottom of the ocean. Yeah, it sinks to the bottom of the ocean where it lands on the ocean floor. Yeah, dead dinosaur fish now gets covered by sand. Yeah, this continues over millions of years until there are layers and layers and layers and layers and layers and layers. The water's up here, by the way. This is the water. This is the sand. Layers and layers and layers of sand. Fish gets buried and gets squashed and squashed and squashed and squashed and squashed and squashed. Yeah, and then over millions of years, the fish kind of breaks down. It gets eaten away. This is the remnants of the fish. Yeah, it gets broken down until all the other elements, oxygen gets reacted away. Oxygen atoms get reacted away, nitrogen atoms get reacted away, sulfur atoms get reacted away, and eventually after 60 million years, there's only 2 elements left, and those 2 elements are carbon and hydrogen, which is what crude oil is in different length chains. And they recombine to form the simplest molecules they can, the most stable, and you end up with reservoirs of crude oil. So when you drive to school, you are literally burning dead dinosaurs. Quite literally. When you're filling your tank up, you are putting dinosaur fish in your fuel tank. Yeah, it's just been there for 60 million years and has become crude oil. But you need the hydrogen. When carbon dioxide only has carbon and oxygen, there's no hydrogen for it to become crude oil. That's so cool. Isabel says, how long will it take for the crude oil to run out? Yeah, they could expedite that process. Oh yeah, it's really difficult to speed up a 60 million year old process. It's kind of tricky that, like, somehow. They're working on it, Ruby, amazingly, but it's not a good idea. We don't want to create more fossil fuels. We don't want to create more hydrocarbons. Hydrocarbons are bad. You're making carbon dioxide, which is the whole problem with our atmosphere in the first place, because we're pumping CO2 into it. Yeah, what we want to do is replace it with things like hydrogen. Yeah, we want hydrogen. We want electricity that's free. We want fusion. The answer is fusion. Oh, I'm getting into a very big conversation. If people want me to have a rant about that, I can. But how? Yeah, I agree. Yeah, we need to be swapping for things like hydrogen. But then the problem with hydrogen is hydrogen is nowhere to be found. You have to extract hydrogen. To make hydrogen, you either crack methane, lol. So you take a hydrocarbon, a fossil fuel, and you turn that into hydrogen. You crack the hydrogens off it. And guess how you do it? You do it by heat. Where does the heat come from? From burning fossil fuels. The other way of doing it, this is cracking methane. The other option is, and this is the most done one at the moment. Actually, no, that one technically is the most done. The other one is the electrolysis of seawater. You remember this? Electrolysis of brine. You take sodium chloride solution, aqueous, you run it through electrolysis, and you get chlorine gas, hydrogen gas, fuel, and sodium hydroxide. So you can do it that way. But where does the electricity come from? The electricity comes from burning fossil fuels. So pointless. Yes, but the water vapor doesn't remain in the atmosphere. It comes back down as rain, Yusuf. We don't mind about water vapor because the equilibrium in the atmosphere will shift to compensate. It'll just come back down as rain. It won't stay there. Oh no, we have 15 minutes left of class. We've only covered 1/3 of gases. I know, right? Yeah. Okay, I know, right? You guys have caused me real trouble. Brilliant. So, solution. There is another solution to carbon dioxide. The other solution, by the way, but this is only a small. The other. Yeah, okay. We need to get back to iGCSE. I know, right? So, carbon capture and storage is the most viable method for dealing with CO2. There are other methods of dealing with carbon dioxide on small scales. This is done on the space station. So number 2 is done on the space station. So the space station has people living on it all the time, so CO2 builds up. And what we use is lithium hydroxide. Lithium hydroxide reacts with carbon dioxide to form lithium carbonate. Lithium carbonate and water balance the equation. I think that now adds up. Should do. 2 lithiums, 4 oxygens, 2 hydrogens, 1 carbon. So you can actually react it. Now the reason the carbon dioxide is a gas, and now that becomes a solid. So, but this is only done on a small scale because you'd have to make lithium hydroxide. And if you want lithium hydroxide, you've got to make it, which requires energy, which then requires the burning of fossil fuels, which releases CO2 in the first place. Nightmare. Nightmare. Absolute nightmare. Okay, right. So, carbon particulates. Global dimming. Carbon particulates. Particulates. Solution number one. Solution. Number one. Complete combustion. Complete combustion using excess oxygen. It's basically saying don't burn things badly. Seems reasonable. Ensure complete combustion. I like that word. Ensure complete combustion using excess oxygen. Then you won't get carbon particulates. Number one. Number two, filters. Number two, filter. Because this is a solid, we could technically filter it out. Yeah? You guys know what happens when you put the beaker on a yellow flame. It turns black. The particulates are sticking to the glass. Yeah, so we could filter these out. The problem with filtering is filters require cleaning. Filters, however, require cleaning. Require cleaning. Or replacing, stroke replacing. Not ideal. Yeah, not ideal. You guys know the filter paper gets clogged up. Next, what was our next problem? Gas. Carbon monoxide. Very little you can do. Carbon monoxide is actually CO gas. So in this one, we have a catalytic converter in our car. Yeah. Cars produce CO gas. So are fitted with a catalytic converter. Some boys might have heard of these. Some girls might have heard of them too as well. I'm not being sexist. Girls who like cars as much as boys. Yeah, catalytic converter, and that gets rid of the carbon monoxide. If you want the equation, it actually does this. This is the equation for the catalytic converter. There we go. I think that now balances. So it converts the toxic carbon monoxide and the acidic nitrogen monoxide into CO2 and nitrogen. That's what it does. And the problem is, you see, so we remove toxic CO and acidic NO, but, and this is a big but, yeah, but CO2 causes global warming. It's not great. It's one or the other. This is a nightmare, folks. We're destroying our planet epically, and we're not slowing down anytime soon. Makes me very sad. Acid rain. I like it. Acid rain. So we're in the last one now, folks. So SO2 and NO2 cause acid rain. Now we can't stop. We can get rid of the NO2 in the catalytic converter. Yeah, but the problem is we can't really stop the rest. So what's going to happen is the acid rain is going to end up causing acidic soil and lakes. Now these we can treat. Yeah. So to treat acidic soil and lakes, we add calcium hydroxide. That's what we add. Or calcium carbonate, either one. Or calcium carbonate. But most of the time, calcium hydroxide is the one that we use. Slaked lime, that's what that's called. Yeah, and of course, what happens is the calcium hydroxide is a base. Yeah, it reacts with the sulfurous acid in the lake, turning into calcium sulfate and water, and then you can balance the equation. One calcium, one sulfur. Oxygens, there's two there, so that's probably now going to add up. Two oxygens, four hydrogens, all adds up. And this is acidic, and you're just forming a salt and water. There is something else we can do about the SO2 actually. So just one more note on SO2. So where does the SO2 come from? So where does SO2 and NO2 come from? So the first one is sulfur. Sulfur is, I'll actually write the word. Sulfur is an impurity in coal and oil. So it's actually in the petrol, combustion of sulfur and nitrate. No, not nitrate, nitrogen. So the petrol you put in your car, the petrol we put in our car, yeah? So when we're filling up with petrol, yeah, the petrol contains, so let's say we're going to add, the petrol contains trace amounts of sulfur, a small amount of it, impurities, and they go into your fuel. And then, of course, what happens is the sulfur burns in oxygen in the car to make SO2. But by the way, this is the bit for your exam. Sulfur is an impurity in coal and oil. Yeah, and then it burns to form SO2. The nitrogen, on the other hand, is coming from the air. Yeah, so then I should do, where does the SO2 come from? And then where does the NO2 come from? The NO2 comes from the fact that nitrogen is in the air. Nitrogen is in air, along with oxygen. Along with oxygen. Now, the cars breathe in oxygen. We know that. The car engine, yeah, the engine in the car, yeah, this block engine here, yeah, with your cylinders going up and down, your engine has to breathe, it takes in air for oxygen because it's taking fuel from the fuel tank, yeah, it takes your petrol in, mixes it with air, yeah, and then burns it in the engine to create your energy, which pushes your car forward. Yeah, but unfortunately, along with the oxygen goes nitrogen. And at high temperatures, so nitrogen along with oxygen, at high temperatures, at high temps, which is what a car does, at high temperatures, the nitrogen reacts with the oxygen to form NO2, and then you have to balance. There you go. So key points, at high temps, and nitrogen is in the air. Key points for this one, sulfur is an impurity and reacts with oxygen to form SO2. So one thing we can do with the sulfur, desulphurization, remove sulfur from fuel, remove the impurity. It's called desulphurization. Desulphurization. Yeah, desulphurization. Some do it better than others. It's actually a legal requirement in the UK. Right. I'm pretty sure we've covered them all. I'll leave it there today, guys. It's been an entertaining lesson. We've covered quite a lot there, guys. Wow, formation of crude oil, loads of stuff. Wow, I'm really sorry. That lesson felt a little bit slapdash. Like it felt a bit all over the place, and I apologize for that. I feel like we've done some really good chemistry. There's been some really wonderful chemistry. We even did a coughs in this lesson. It's really nice. Like, I really like it. It was a lovely lesson. Thank you for all your contributions. Lovely to meet you, Yusuf. Thank you for joining my lesson today. Really enjoyable. Thank you. Doesn't the hydrogen also release hot water vapor? Yes, yeah, I've already answered that one. Guys, I will leave you be at this stage. There we go. Let's see if I can do this without my mic crashing. Oh, Sanjan, hello. So is this a live school lesson or is this a tuition lesson? This is a live school lesson, Yusuf. Guys, I hope you have a really nice I hope you guys have a really nice rest of your day. I will post the homework on the Google Classroom for you guys to have a go at. They're all exam questions that I've taken over the last 10-year papers I've just taken out all of the ones that are regarding pollution and its problems. Are the exams cancelled this year? Like I said to my year, sorry for crashing in, guys. Yusuf, it's absolutely fine. It's nice to have other people joining the lesson, especially ones who are as polite as yourself. Thank you very much. Saranjan, are the exams cancelled? Currently they are. It wouldn't surprise me if they could reverse that, though, if the number of cases in the UK's go down. So focus hard on doing good revision. Recognize that your teachers will be the people giving you your exam grades. Be nice to them. Do the best you can on your internal exams or internal tests. It's important. Guys, have a great rest of your day, and I will see you soon. I'll post the homework on the class. See you later. Oh, just to also let you know, I'm also finishing off my paper 1 exam review at the end at about 12:30. At about 2 o'clock today. So I will see you guys later.